Very nice to be here again for HashiTalk. My name is Arnaud. I work at Microsoft, and today's session we're going to spend a little bit of time focusing on the Terraform module that we issue as part of the Cloud Adoption Framework. So let's spend a bit of time on that and focus on what we're doing. So first, just a couple of introduction on Cloud Adoption Framework and Terraform. You probably have seen that into my previous speeches, so I don't want to spend too much time, but it's been 3 years that as part of Ignite, our technical event, we announced that the Cloud Adoption Framework for Microsoft will publish and maintain artifacts on Terraform. So not only on first-party ARM templates and Bicep, but really creating artifacts. And I mean really not samples, because we've been doing sample for years, but artifacts mean something that you can use and that is a quality thing that you can use into a deployment. So at the beginning, there was a lot of discussion around, hey, why do I need a framework? Just give me terraform.exe and life would be easy. But of course, this concept of dry infrastructure, that's really something that we want to do. So don't repeat yourself and make your code smart, because inevitably, what we see is when you start writing code like this, and actually this is an example of the code we used to publish, you can clearly see that there's no intelligence into it. There's no building on the experience we had from previous development. There's not really anything that makes it smart, make it centrally reusable by other teams. So it became really clear that we needed to focus on delivering quality for that. And module was part of the things we needed to spend some time. And let's say we really see it as a necessary evil, but we clearly see that this is one important part of the components that we needed to create and maintain. So in this framework, actually, module takes part of it, and we really want our customers, our engineers at Microsoft or anyone in the ecosystem, not to spend time deliver modules, because we know it's a lot of time consuming for everyone, but really reuse modules that are proven, and that's really one of the key aspects of it. One of the key aspects of the framework is really using the state management and having a set of ways to delegate the state management with the framework. But I'm not going to talk about that today, because there's a lot of readings that are available and that we can spend time on. So ultimately, Terraform, again, there's a lot of aspects of it. The DevOps ubiquity is something we worked a lot to be able to reach any pipeline, any CI/CD with Docker containers, focusing on the developer productivity with the continuity, because we clearly see very often as well a discrepancy between the experience, the local experience on your laptop, and what happens in the pipeline. And if there's discrepancies, this means that basically you are losing a lot of efficiency when you are troubleshooting, when you are deploying things. And we are offering easy state management techniques that basically rely either on Azure RM on the storage backend based on Azure storage accounts, or based on TFC and TFE, Terraform Cloud and Terraform Enterprise. One aspect that we spend a lot of time as well is the transparent composition. And by that, meaning that we're able to work in a team, and one team will work and build on top of each other. So from one team, you can read the state of another team and compose and create like that an enterprise hierarchy where you manage the risk, and you don't have everything into the same TF state, because that's really one thing that we've seen quite a lot, and that we found quite disturbing to see that a big organization could be basically stored inside the TF state. And I think one of the most important aspects that we have is really the everything as configuration. Tend to see IAC, now it's EAC that we're saying here. That's just me abusing the language, but the idea is that everything has configuration. So not only the infrastructure, but everything on Azure being automated. including the creation of the pipeline, including the creation of the repo using different providers that we have on the market. So if we look at all the components that we deliver inside CAF, there's many items that you will find. And really, it can be confusing at the beginning to see so much assets, but really the idea is to be able to make you free to use or reuse some components, either all of it if you don't have a DevOps approach and you don't have the pipeline, or just part of it. For instance, we have other projects at Microsoft that just use our Terraform provider. So we issue a provider for a naming convention and for basically dev and test integration. Then this provider is used by this other team, and that's totally fine. It's living totally outside of the CAF and outside of the CAF module. That's totally okay. So all those components are available. Today, I'm going to talk about the green box that you see here, the CAF module. That's really the module that we use to integrate all the capabilities together. So we have the Azure Landing Zone module that comes here and deploy the policies and the management group, and that's how we leverage it. But the CAF module, we use it to deploy anything else on Azure. So IaaS services, as PaaS services, absolutely anything. So the CAF module, number and growth, this is something that, yes, we're quite happy that actually people are using it. So that's the first module consuming Azure RM, so the Terraform provider for Azure, and Azure AD, the Terraform provider for Azure Active Directory. And that's just figures that I refreshed just off this morning, but we are 700 and almost 40K downloads of the module. So for us, that's really beyond being happy with a big number, of course. What's really important is that at least we know that some people are using it. We know it's useful for the community, and we know a thing or two about its reliability, if it's good or not, and if something needs to be improved, then we have live and direct feedback. So let me answer one of the core questions of this show, how we built the most used Azure module. Well, the answer is very simple, is with you, with the community. So I took a snapshot yesterday on GitHub during the activity during the one last month, and most of the contributions are actually not done by Microsoft employee, which to me, it's really, really healthy. It's not like we're telling you the truth from Microsoft that we know. Nope, we build together, we co-engineer artifacts together that are useful for the community, because we're not as smart as everybody together being smart. So if you can see here on the contribution, 21 authors, many guys, Ahmad, Anthony, Hyperfocus, Sean, Paul, Simon, Nick, all of the guys that are contributing to the framework regularly. That's really for us, really the good thing is that it makes it much more quality than we could have ever done it alone as Microsoft. And that's really cool to see the issues opened by the customer, the partner, the Microsoft employee, and the pull request. And pull request fixing a bug. Let's say one partner finds something, the other partner fixing it, or we Microsoft at the core team fix it. That's really, honestly, an amazing journey, and a really big, heartful thank you for all of our contributors. And that's just 21 authors from the last month. So there's many more that I couldn't mention in the slides, in the name, but really thank you all, and keep it going. So if we review at the core pillars of the module, what do we do, and what do we do inside the coding practices? So first of all, what we've seen is at the very beginning, like everyone, we did the same mistake, like everyone. So as I mentioned, we're not smarter, we do the same mistake, we learn out of it, and we build it together. So at the very beginning, what we were doing is, like everyone, we were doing small modules. And this is very intuitive, because you say, okay, microservice, my module does one thing, does only it very good. And yes, that's true. But the reality is that in a world where we are constrained by DevOps engineers, by the skills, by the people, a number of guys I can get in the team, for instance, then we clearly see that it's becoming a humongous work. You can see the job. I have to have a deployment where I have Key Vault, so I do a Key Vault module, then I have VNet, then I have a VNet module, then I have a virtual machine module. And then every single update I'm doing onto one module, I need to qualify and verify it with the other module, which is good to manage the risk. But at the end of the day, ultimately, all those components, they're used together. Because most of likely, if I'm doing a key vault because I want to use it inside VM to store the secrets, or I'm going to use it inside a VNet and I want to restrict the access to the key vault from this VNet. So actually what we find is creating single and simple module is easy, but brings no value and brings a lot of work. Whereas putting the things together is really the hard job. So the integration time is really huge, and adding capabilities, maintenance over time, and testing is super hard. We've seen that as well in many organizations. We create a CCOE and a development project. Many people are joining the parties. We have a lot of coders, but after 2 years, we're still on Terraform 10 versions behind. I see even a lot of customers today that they are still running on Terraform 11. And this is really, really annoying, because we came to ISE at the beginning to increase the speed and increase the velocity on which we introduce changes. So one of the things that we decided is really to do it together, build that with the community, and build what I call the super module. We have super app now. I liberally use the term super module to say we implement all the capabilities inside the module. Now, this has been capable, we've been capable of doing that starting in Terraform 0.13, which, remember, introduced the capabilities of doing conditional submodules. And that's really what unlocked for us this scenario. So as a matter of fact, our module, even though you could reach potentially all the sub-modules, including all the different capabilities, but really what we are supporting mainly is a single entry point. So basically, as you see here inside the slide, we are basically calling the module, and either we have the strong pinning here from the registry, or here when I'm in dev cycles, I'm sorting it on a particular branch or sorting it locally. And then you see that inside this module, inside the invocation of this module, I'm like sending it all the arguments. And you see that if I have a data factory, then I will do data factory. If I have database, then I will do database services. So basically, and if you don't need database, you just remove this variable and the module will not iterate on anything database. But anyway, if the memory structures are empty, then it doesn't iterate at all. So that's the example that we have here on iterate on everything. You see that I'm having the module Sentinel automation rule, and I'm using it as the path for the submodule being there, and I'm just doing a try for each. So if I have local security automation rules full, then I'm iterating into it. If not, empty structure, I don't do anything with this guy. And that allowed us to really being able to compose configuration files very easily. So basically, we have a set of examples, and now you can play Lego, and that's what really I love our architects to do, which is really copy and paste code snippets and composing super fast. Just looking at an architecture diagram, being able to compose a complete and complex architecture very fast. So if you've done module on your end, you probably know that once you start doing module, once you start to have dry modules, basically you start to have kind of a meta language that is something like Terraform, but not exactly like Terraform. So this is what we do as well. So you see that inside our iterative structure, what we have is here, I put resource group equal. And here I instantiate as many resource group as I want, as many VNet as I want. Here, just one VNet, 2 resource group. And now I need to determine how to link this virtual network, so the VPC in AWS term if you want. How do I link it to a resource group, which is the admin construct to put objects together inside Azure. So I can link my resource group by the key. So here you see resource group key equal at vnet region 1, and that's the key here, vnet region 1. That's the iterator that we use. We call it the key and we refer it there, and that allows us to not care at all about what's the real name put in as an input by the user. So we have that way to key association pattern. And what we see is same thing. I'm creating the VNet here. I'm creating it inside VNet region 1, and I have the rest of my VNet being declared here. And if I declare a VNet peering, for instance, what I'm having is here, you see I'm declaring a peering between this peering object will have this name in the Azure portal from this VNet key. So from the key of the VNet here. So here it's different names, of course, but that's just examples. And here you see that I have something a little bit weird, which is VNet key, and I have LZ key. So this is one way to do dependency injection. So it's another pattern that we are using, is you are able to compose basically from another state file. So the module has the capability, if you feed it with the right variable, to read from a previous state, load it into memory with a declarative structure, and automatically go and reach for this object into the object structure. So you are able to do cross-state composition without even writing a line of code. We manage the data sources for you. As long as you are using landing zone, it's totally transparent for you. You can implement that manually as well if you want. But there's three ways to do composition. So the key-based composition, as we see, the dependency injection from other state file, I will show that in a minute, and also the literals injection via the resource name or the resource ID, because there's always things that you will have to manage that are not into the Terraform world. Let's say that somebody had a brilliant idea to go on the portal and create manually. Fine, we can accommodate that as well. So for many of the resources, you have the possibility to do a literals injection, as we call it, to do say, okay, that's the resource ID for this guy. So peer this guy that has been deployed manually, peer it with the VNet that you have it here. And very easy. This is something that basically you go into the portal, you get the resource ID, and you just inject it in your configuration file. Works fine. It has the caveats that since the life cycles of that is not inside the environment, then it means that, well, you have to manage it slightly differently, but at least you have the flexibility to do whichever you want to do. So if we look at the dependency injection via remote landing zone, the module has this capability, as we said, to inject complete other TF state files. So here, when we have a module and we call it and we put it inside a structure called landing zone, then we say, okay, I'm going to read another state file that is here stored on those objects. So here I'm declaring a landing zone that will be stored on Azure storage account that will be into our hierarchy of state level 2. And that would be called this way for the key and the global settings key. And then basically what we're going to do and say, hey, load inside a memory object called management from this TF state called management.tf state inside this workspace and inside this level. And as long as you do that, remember previously we had the LZ key pattern inside our code, then it will look for that object under management. If I put LZ key equal management, then automatically the state is loaded and I'm getting it from either here, you see it's from Azure RM backend storage, or I can read it from Terraform Enterprise or Terraform Cloud Workspace. It's a new feature we are releasing actually this month. So now we see the config side on the previous slides. Now, if we look at the code side, of course, it's a little bit more complex. So the code will accommodate for you the lifecycle of those objects and will have the responsibility to read across those objects and compose. So if we take the example here of the VNet networking, you can see that we are injecting all the things called here local.combineObjects, application security group, local.combineObject, DDoS services, etc. So that's really a way to the local.combineObject. You'll see that throughout our code, and it's really what loads the object that we just created locally, as well as the objects that are loaded into memory from the previous state. So from that, what you're seeing is that we are going to read an object either locally or from the remote landing zone. So maybe to be a little bit more explicit, let's look back at the code. If you see here inside the VNet, here I'm creating a VNet and I'm creating that this going from this resource group. So you see here that I'm loading combined object resource group, all the resource group, and I'm trying to load here all the resource group that are either from a remote landing zone, so resource group.lzkey, or read it from local configuration file, so from my local landing zone. And then you see that we do the object resolution. So we try to get value.resourcegroup.key, and then we get the key.name to resolve the full complex object. So the code is indeed a little bit more complex, but what it allows us is the configuration to be much more simpler. And for an architect, for the guy that deploys the configuration, it's much more productive than trying to write a code again and trying to make an optimized code. And the last pillar for us is, as you mentioned, when you use our module, you use variables, you almost of the time don't have to write Terraform code. So for us, configuration is the contract. So when you see all the samples and everything, it's like a contract to say, this is how a config file looks like, and this is how we're going to load it. And that's the idempotent composition unit. So what we do as a core team is we issue the prototype of the config file, and the config file, what we make sure is over time, as the versions of the code is upgraded, then we make sure that there's no regression that is being introduced and that it's not basically being deleting the object or recreating the object. So we were quite surprised that most of the time it works. Most of the time it's totally transparent for the users. So we sometimes have to update the logic of the module to basically accommodate the changes that has happened in the provider. But most of the time when we use configuration file as the contract, then we're able to update over time and have an evergreen Terraform configuration. And to us, this is really, really, really important because remember, as I was mentioning before, we see customers still running Terraform 11. We still see people using Azure RM 2.x, 2.1, 2.2 provider version for Azure RM. Now, what we've been doing is with TFVARs as a declaration file, we've been able to migrate customer transparently from Terraform 0.15 to 1.1. We've been able to migrate them from old module in last July to new module out of March release. And with that, 0 changes because the config file, again, is the contract. We respect those contracts and there's no breaking change. Sometimes there are breaking change, and it's the part that we do, all of us as a community of engineers very bad, which is reading the documentation. And when we read the documentation in upgrade.md inside the module, we declare here what are the changes. So we say, hey, we are upgrading to this version of the provider. So this structure, we couldn't update it. We need you to take action to update it. Like a new attribute has been added, and we cannot automatically interpolate that for you. So go there and add this attribute. So this is how we operate. This is how it works. And so far, so good. What we do is really, of course, get the feedback from the community, monitor the deployment. So there's Gitter, and we have direct channels to administer all the customer deployments. But really, there's a couple of lessons learned, and I want to show you just a bit of slice of code just to raise your appetite on that. So there was something that we've been doing from the beginning, well, not from the beginning. In the middle, we start to look at structures and say, Coalesce is quite a nice writing because it's really allows us to see exactly what we're doing, and it's you can spread it across multiple lines, which is good because it's not that often in Terraform that you can do that with expression. So we were like very happy to see that and say, okay, we see the coalesce. You try local combined object either in the remote landing zone or in the landing zone key or from the literals injection from the resource group name. Sounds good, right? Intuitively, it's super readable, it's super good. Now there's a little problem with that, is that at plan time, the coalesce and the try are quite adventurous, or I should say lazy. Because basically what happens is, if I have in my API management a declaration structure and I had a resource group, then it will create a new resource group in my structure. And then when I evaluate the resource group name for API management, Terraform will say, well, you know what, there's resource group, there's new resource group coming up, so I don't know the name of the new resource group. Even though the previous resource group exists and there's absolutely no change, but since coalesce and plan and try is not evaluated as this time, then we're just left in the blind, and then Terraform will destroy and recreate everything. Lessons learned. So the refactoring that we've done here is we force the graph evaluation and assessment. So we do a can first. So we evaluate the literal first, the each.resourcegroup.name first. And then if that's the case, then we try those literals. If that's not the case, then the lessons learned is if you go to the variable, so you put the variable first, and then you force Terraform to evaluate the remote or the local landing zone with a try. Now, the surprising fact is that if you force the variable by the local combined object, then the try being inside the structure doesn't matter. It will still evaluate it, because as an entry point, we force it to get to the variable and then evaluate the try. But if you put the try as a leading here, if you do a try local combined object, same thing, plan time, lazy plan time, won't evaluate it, create a bug. So that's what we've been doing in the last couple of releases. We got rid of the coalesce structure and being more into structures that are perfect for plan time. So first lesson learned, that's something that we learned wasn't too much of a hard way, but something that we improved and that we see with the community. Another example, and a much more happier story here, internal refactoring example. For instance, data factory has changed from referencing the data factory name into the data factory ID when you create a data factory element. So the good story here is that if you're using the CAF Terraform keys, you don't need to change anything, because after all, it's all internal refactoring that we do. But if you're using literals, of course, you need to update your config file, and instead of referring the data factory name, the data factory ID. So what it looks like is here, before we read data factory name equal, and then after data factory ID is that. Simple refactoring. But again, when you look at the internal refactoring configuration file, 0 changes, because I'm still referring with the key, and ultimately the graph will recalculate when I upgrade to the newer version. It will recalculate the data file, relocate that, okay, now it's not the ID, it's the name, but at the end of the day, it's the same object, so no change needed at all in your configuration file. So that's a happier story, and the other lesson learned that we discovered during those gigs. Now, quick question is how to consume the module. So many ways, actually. We have some customers that are doing a direct consumption from the registry. So we just strict pinning from the registry. So if you go to the Terraform registry, you can see here that you have the module. We choose the module from Azure CAF. You get the instructions here. You get the right variables to fit it. And there you go. You see that this is one way to consume it. Another way to consume it is just transparently use the broader product, the landing zone. So when you use that, you are sure that every release is consistent, upgraded, uses the latest module, and does this integrated updates for you. We have another way to consume it, which is growing more and more those days, which is people running their own fork. So basically, they just go and get the content here. You go to the GitHub environment, and people will just fork this guy here, and then they will just basically have into their organization their own variations of the module, because they want to go faster than the speed that we're going, and this is totally fine. They might want to try new stuff, and the module, we take some time to integrate the latest feature, because we want to validate, we want to make sure that we don't have regression testing. So we do that. And actually what we've observed is those partners that are contributed, our customer, Then they use both. Actually, they use their fork and they use the upstream, this one, and then they resync from time to time. And this is how we get the contribution. This is people basically just resending back to the community the contribution they've done to the environment. So I just want to show you an example of just consuming the module locally here. So I'm just inside the module that I've cloned locally. I've done Terraform init. I can do a Terraform plan, filling it with the variable file. You see here, you see I'm using appim. I'm going into this configuration and I'm doing very simple stuff. I'm just saying, hey, deploy something in Australia East, create one resource group, and link this resource group RG1 to this API management. So here you see, it's just a Terraform plan giving this variable file. And you might think that, okay, there's a high cardinality, there's a lot of objects inside this stuff. There's a lot of top level objects that are redirecting to the submodules. It was a bit slow in the previous releases in 5.5, not because of the high cardinality, but because of some misusage of the VM extension. But right now, in 5.6, which we are releasing in a couple of weeks, basically the plan time for complex, even for complex plan, is around 1 minute, 1 minute-ish. So not too bad, and that's what we are seeing. Building with the community, to us, again, it's super important. So one of the questions is, hey, how do I contribute? Hey, this is the plan finished. So you see, we're creating the object. But okay, back to the slides. How do I contribute? This is something that we get very often. How do I make sure that I make sense in the community and that things are going well? First thing first, open an issue to tell us, hey, this is what I found. There's a bug, or I need this feature. Then we can do the triage. We can say, hey, it looks like a bug, or it looks like a feature that we might need. People can plus on it, can say, hey, I'm desperate for that, yes. And other people might say, hey, look, I have a fix already ready for that. You can look it in my branch. So sometimes a solution for your problem might even be faster than you expect. So if it's not the case, you can still open a PR. And once you open the PR, we do a first pass validation. So it's a mix of basically verifying that it's matching with the coding style, matching with the remote composition and local composition object. Then once we have that, we do first integration testing. Then if we fast forward, we do regression testing, because remember, the config is the contract. So if we are changing a behavior, we want to make sure that there's no regression created. So we test against the previous versions to see if, when I'm applying this new guy on top of the previous guy, is it creating a rollback? Is it creating a change? And if yes, is this an expected change or no? Once the regression test has passed, we do second pass review, again, which is a mix of human and automated. And if everybody agrees on that, then we go for the merge. So that's really the simplified process on how to contribute to the module. And again, this is really something that we love and value, which is the speed of innovation we can do with the community, with you guys contributing, you guys adding some features and really making things faster and more reliable for everyone. So there's a one-stop shop for all the docs. We've acknowledged that, yeah, inside the CAF Terraform, there's a lot of components, and sometimes the documentation is a bit everywhere. So now we just created ak.ms/caf/terraform, where you have all the guidance for all the components and things we have inside CAF Terraform approach. And same thing, it's on GitHub. So you can raise a PR to change the doc if the doc is not good. And yes, the doc is not good. It always needs to be improved. So go ahead and send out the PR. So same thing, a couple of points to get you started, either consuming the module directly off the registry, consuming it off the landing zone, or if you want to write your first contribution, there's a blog post I've done. There's an article from the very famous David from HashiCorp. David writes, in APAC that documented a little bit how to use the CAF module inside the registry. And another one is Gitter. So we have a very live community of folks on Gitter that are helping each other, very smart guys. And that's really one of the way that we like to learn the usage and what people are doing out there. With that, thank you